So hopefully you know a little, you remember about functions. So this is like in math we talk about a function. And we say that x is an input variable and y is the output variable. Okay? And then, you might have something like y equals f of x equals, something like 2x minus 6 or something like that. Or you could have some other function, like it might be 2x squared plus x plus 6 or something. Okay, so something like that. But, we also will write this. So first of all, it doesn't matter what I call the output variable. I can call it z, and I can have x as the input variable. But what I want to do this time is that. So what I'm saying is that z is a function of two variables, and that's just a simple thing, really. Just like this. For example, you might say, let's say 5x plus 3y maybe minus 8. And, as I said, these could be, it's just trouble for me to put a square up. Well, I guess not so hard, is it? I could do that pretty easily, actually. So I'll do it. So something like that, and this could be like a cube or 5. And I could even make it x, y, anything. Plus 9, anything I want. Anyway, this would say that z is a function of two variables. So we have two input variables there. And so if I said, okay, f of, sorry, small f of 2 comma 1, that would mean, if I'm talking about this f here, then I'd say put in 2 every time I see x, and 1 every time I see y. So I'd have to write 5 times 2 squared, so that's 5 times 4. This would be 3 times 1 to the 5th, that's 3 times 1. 8 minus 8 times 2 times 1 plus 9. So whatever that equals, that's what I would say equals this, right? And then, I could do this. If I want to, I could change the output variable again here, and I could write like this. Whoops, not like that. So instead of calling my variables x and y, I could call them x1, x2, x3, whatever I want to call them, I can call them. And I could make up some function over here of these three variables. I could just mix them up and set them over here, and that would be y. And then I just say, if I wanted to know f of 1 comma 2 comma 5, I'd put in those values over here, and that would be the answer. So my point is that you can have three inputs, or really, there's no reason why we can't, there's no reason why we can't do that. In other words, say we have more variables. Maybe we'll have 4 variables or 5 or whatever. Okay, so the number of variables that a function can have as input variables, we can have as many as we want. So the same thing in R. So this is a function. It's not called f. It's called the mean. That's a better name because it makes it clear what it is. And it seems to take more inputs than we thought. So one of the inputs, we've already used it. So like simple example was over here, right? So I created a vector 1, 2, 3, which you don't know what a vector is, but anyway, I have this set of numbers 1, 2, 3, and then we asked, what? Oh wait, that's weird. I made a mistake. Maybe I confused you. That was wrong. I meant to write mean of x. Let me try that down here again. I don't know if I'm gonna, well, okay, now I do that, and then I meant to go mean x, right? That's what I meant. We still get 2. So, I know that this is one of the variables, or we call them arguments. One of the input variables. We also call them arguments. So I'll usually call them arguments, actually. Not always, sometimes input variable. So one of the arguments or the mean is this. But looks like, according to the documentation, that that's just one of the input variables, and there are other ones like this one and this one. I'm not sure if this means there are more or not, but there are at least this one and this one. So I'll just explain to you what these are about, but we'll have to come back and do it again later, but just so you're not too confused by it. The trim, and it tells you what the arguments are in the documentation. So it says x is an R object. Now, that's not that clear to us right now, but basically it just means, for our purposes so far, it just means like it's a list of numbers. Okay? So that's what I just had 1, 2, 3 as my list of numbers. And then there's another argument here, and it's called trim, and that is a fraction from 0 to 0.5. And what that's about, now, this is going into statistics, and I don't really want to go into statistics, but I guess to explain this, I'll mention it. Suppose I have a list of numbers like this. Suppose I have a list of numbers like this. So this could be people's heights in centimeters, right? That's possible. But suppose that somehow, for some reason, there was also this number there. And maybe that number there. Okay? So these seem like they're wrong, right? So if I take the mean of these, or suppose I leave this out, or let's even say let's even make it worse. Let's say it was 400. So if I took the mean of these, and I wanted to say, oh, the average height of these people is blah, 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 whatever the average is, and if that 400 is in there, it's really going to mess things up. It's going to just totally make it unreasonable. So sometimes we're afraid that there might be some kind of wrong kind of data in the data set, and we don't want to get messed up. Like, we're not looking at it, with our own eyes. We're just letting the computer look at it, and we don't want to risk the fact that there could be some messed up data in there that we're not, that if we looked at it with our eyes, we'd say, oh, that's wrong, but we're not doing that. So so to calculate the mean, we might use what's called the trimmed mean, which means we'll cut off, we won't include in our calculation like the highest 10% of the numbers and the lowest 10% of the numbers, or something like that. So that way, maybe I would avoid this value. This would get thrown out, and maybe, what's the smallest number here? This one might get thrown out. So that would be called the trimmed mean, and I don't know exactly what percent we're trimming here, but some trimmed mean. Okay, and that way we would avoid these what are called outliers, these things that are really far away from the rest of the data. They lie far away from the rest of the data, so they're called outliers. Okay, so we could avoid that, and that's called a trimmed mean. And so this allows you to say, okay, I want to use, I want to trim off the, what does it say, the fraction of the observation. So I want to trim off 10% from each end, or something like that, or 5% from each end, or 20% from each end, whatever it is. So you can put that in. So you can here they're saying trim is equal to 0, but so they're not trimming anything. But I think we had an example here where they're going to trim 10% on each end. Okay, so you can do that. And then this one, this is another now. Okay, and then this argument is sometimes when you have data, and this is all about data really. So sometimes when you have rows and rows and rows of data, some parts of that data will be missing. What I mean is, maybe you have a data set like this: name, height, weight, income. So John is 178, weight is 60, income is 50, Peter is Andy, Paul, Wendy. So you have some data like that. But you might, for some reason something was missing, or got corrupted, or something happened to it, and that's missing. Okay, in your data set. So then a lot of the analysis that we'll do will get messed up, will get confused or whatever if there's some data missing. It needs to have all the data there. So maybe the mean does that for some reason. If some data is missing, maybe it'll get confused or something. So or other analysis will get confused. So what you can do is say NA remove. That means NA means not available, means it's missing. So NA.remove, if you set that equal to true, what that would do is, in this case, it would just delete this row of data because this was missing something. So it would just throw away this row of data. Sometimes you just want to do that. You know, if you have, suppose I had 50,000 rows of data, then I probably don't care if I throw away a few rows of data because I have so much anyway, right? Or suppose I have 1,000,000 rows of data, then I don't care if I have to throw out a few rows because they're missing data. So you can choose to set NA.rm equal to true, and then it will remove those, and then you won't have that headache or that problem of missing data. Okay, or not, part of it is messed up or corrupted or not available. In other words, in R it's called NA, not available. Okay, so that's what that. Now one last thing is that now notice that in the first example we didn't supply those any of the other arguments. So many functions in R and many functions in programming languages in general have that ability. That is, you can leave out arguments and it will still work. Okay, so we can just do this, but we can also sometimes use more arguments, and that also works. So we can do it either way. I believe, but I forget, that this feature of having allowing to have just one argument, but also allowing to have other arguments as well for the same function, I think there's a fancy name for that called polymorphism, but I'm not sure. I believe that that's what it's called, though. That ability for a function to do that.